This is a concept technology that responds to steep and unstable bluff situations where otherwise buildable land is available in lots, and you've got, in many cases, a higher than 45-degree unstable slope. As it stands, even in a very expensive community where the average home is $1 million, the cost of building where I live is so high using conventional methods that these bits of land on unstable bluffs are largely undeveloped. There are two other connection points that kind of spark this process. One is the ever-increasing synergy around Elon Musk's companies, including solar power, Tesla, and the Boring Company. And the other is homelessness in the United States in a framework where it is currently illegal in many ways to build a low-cost home. And so anything that on a technological level reduces those costs, I think, is significant. So the starting point of this idea, we start with this 45-degree or slightly steeper slope. And let's say there's a street, somewhere around here. You got 30 to 100 feet of or so flat land, and then you have this slope, and there are periodic slides on this slope, as you go along the coastline, etc. So I'm in Marin County, California. So this is a starting point, and the next jump is to a semi-truck version of the Boring Company tunnel borer. So as you may know, Elon is developing not only Tesla and SpaceX, but the Boring Company. And the semi-transport system is the standard transport system to bring, largest possible loads to a site, one. Two, shipping containers are how most semis are set up. 40-foot shipping containers. You can go up to 8 feet, feet high on those, but they're set to handle shipping containers. So the next leap is you have the shipping container, you have the semi. It can be a Tesla semi or any other semi. And then you have the unload process of a semi, which is currently a little bit tricky. Most semis arrive in craning areas where the container is lifted off the container and moved to rail, etc. So the unload process is a little tricky for a 40-foot shipping container. Now, if we assume that there's a boring machine inside the shipping container, this is going to be an incredibly heavy shipping container. And so the process of removing it from the truck is to, first of all, back the truck into position where you want the shipping container, and that would be the site preparation to establish the area ready to begin boring. And on the side of this shipping container, on both sides, you have hydraulic jacks that come down with pads and lift the shipping container above the bed on the truck. The truck now drives out. The shipping container lowers to its position on level ground is the next step. The pads are removed from the hydraulic, which would most likely be a screw function rather than just hydraulic pressure. There's two ways to extend legs. One is to have a nut and a screw type dynamic, where as you screw it this way, the screw extends, and as you screw the other way, it retracts into the nut. And By using the screw type technology with a pad or with a boring with a boring implement, you are then able to remove the pads and drill 4 separate drill points down into the base of the soil. You now have 6 feet of bored steel into the ground as an anchor. And that's important because the shipping container frame, now anchored in the soil, is serving. And this can be prepared in advance with deeper anchors if necessary. I mean, if you've got very sandy soil or there's a certain situation, you would anticipate the exact location of the shipping container and actually pound, as far as 30 foot deep, a steel column in which those points can slide in and then bolt, so that you've got a stable anchor. Because when you're pushing into something with a boring type of mechanism, you can't have your base slide away the way that a light shipping container would tend to do. Now, the second thing that's important is being able to use the back of the shipping container as a thrust point to continually push the cylindrical boring unit forward on tracks that get built out as it bores forward. And those of you who are familiar with well digging know that you can, by having, perhaps on both sides of the borer, two cylindrical hydraulic columns that go back and forth, or tracks that go back and forth, using a motorized gear system rather than a hydraulic pump, you can slowly push the unit forward, then retract, insert another section of horizontal, if it was a well, you'd say pipe, and then push forward again. And all the while, you have this boring mechanism that, the head, which is going forward. Now, the head is circular in a tunnel formation. You can look at, typical bores. And one of the engineering challenges that I haven't worked out is exactly how big does the borer mechanism have to be to simultaneously bore, pull out the soil, and coat every couple of feet with concrete, so that you're building tunnel that you're then boring through, and that as the tunnel hardens, that the tunnel serves as the track and guidance system of the bore, so that this unit can continue out of the shipping container and go along a system that it can then walk its way back into the shipping container when all is said and done, and the borer that particular job is complete. Now, here you show the concept of driving off the street, going onto a flat prepared area, setting down the shipping container at the base of the slope, and then the borer boring in horizontal as deep as necessary. Now, one of the things that's most appealing to me about this is the idea of utilizing unused space on multiple levels. Now, as a designer, and I'm going to take a moment to step back and share why I'm so excited about some of these ideas, because as a designer, what accomplishment looks like, what excellent design looks like technically, is first of all a list of human values. So we have things like building vegetation. Most of us would rather look at, a vegetated slope that is stable simultaneously, and you can plant with slope stabilizing plants, than an eroding, brown slide. So you identify continuums that add value. So building vegetation is one of them. The independence of the occupant is another, meaning one of the ways that you create resiliency in any system is by having each module be self-contained. And to look at the value of this, you just need to remember the Titanic, because the Titanic saved money by not compartmentalizing the underside of the ship, because they were so confident, as it turned out falsely, they were so confident that the ship could not be sunk that they saw no benefit in making sure that if it was punctured here, just this little bit of the hull would flood. If it was punctured here, this other little bit of the hull would flood. And so the grandiosity, and it's always the grandiosity that begins before a fall, the grandiosity that led to the sinking of the Titanic was not compartmentalizing the hull in a way that would protect from flooding. And what that references is the Titanic would still be afloat if a little bit more steel had taken it to the roof so that water could not, if it punctured one area, fill the whole hull. So the same is true in agriculture. If you use a monocrop, then when you have one bug that can wipe out that crop, the entire world's crop goes out. If the world is predominantly, as in the case of bananas right now, you have the whole world growing just a few varieties. And what that means is that a pest, a virus, just needs to figure out how to damage this one variety, and then the whole world's crop of bananas is available as food for this pest. And so the same is true in every area of design. And if you can create independence, insular independence, within each housing unit, you increase the resiliency of that culture, of that group of people, over every single person suffering if one thing goes wrong. And that's where you have things such as, if everyone has the same sewer system and there's a problem at the sewer plant, then nobody can flush the toilet. Whereas everyone has their own sewer system and one person's sewer system malfunctions, then one person cannot flush the toilet. If everyone has their own independent solar power grid and someone else in the other neighborhood, a tree falls on their solar power grid, everyone else still has power. If everyone is relying on an electrical line and a tree falls on the electrical line, then everyone after that tree fell down doesn't have power. And so you have less resiliency the more you interconnect everything. And so you have independence / sustainability / resiliency as a design benefit. Then you have cost savings. Anytime you can build something for less money, it means more people can do it. And it means that there's more money available to do other useful things like vacations or environmental studies or poetry or whatever it is that's of interest. Obviously, slope stability is a benefit. So we have some of the benefits here. Now, there's also a benefit and a pleasure in design when you take something that's not usable and you turn it into something usable. Now, nature doesn't have any garbage. Garbage is a human fabrication. It's fabricated by the phenomena of inventing something that has a short purpose and then not having the imagination to continue the invention into something that has a purpose that's long term. And what we do when we create, for example, packaging, that sole purpose is to help transport a given object from one place to another, and then it's never needed again. When we create, for example, a package, and then lack the imagination to decide what to do with the package on the other side, what we invent is an illusion called garbage. It's natural resources that has been formulated into a design that we don't know what to do with. And because we don't know what to do with it, we just call it garbage. And when we create garbage, we're tying up energy that's not available. And then we spend more energy trying to get rid of the garbage, hauling it away, digging it into big holes. And then those big holes are garbage. We have no use for those big holes. Now, this is all a symptom of incomplete thinking, of asymmetrical thinking, of unsustainable thinking, of unecological thinking, because all ecology is in a circle. And so you have nature gives bananas, we eat the banana, we shit out food for banana trees, and the circle is complete. But when you have a something like a plastic bag, the earth produces oil, it's turned into a plastic bag, you carry something, and then we don't give anything back to the earth, we just dig a big hole and stick a plastic bag there. Now, so when we turn garbage into useful something, we're mirroring nature. Nature doesn't have garbage. Human beings have invented it. And so one of the things that we've created with current building practices is lots of useless land, meaning land that we don't know what to do with. So it just sells on the cheap. We have no use for it. Now, it's incredibly satisfying, and it's one of the biggest areas of value in design when you can take something that was previously a liability, i.e. an unstable slope that's difficult to look at and selling on the cheap, and turn it into something that's very beneficial on multiple levels. So that's a benefit. Then we have speed of construction. If you can move into your house a day after thinking of it, it's 100 times more fun than if you can move into it a year after thinking of it. And it's 100 times more fun than, another number of years after looking at it. And so speed is a value. And reducing stress is a value. Well, if you have reliable technology, because we have reduced labor demands, people are more difficult to coordinate than machines. One of the reasons I used to run a mini excavator for my landscape company was that the mini excavator did the work of 6 crew members. And if I had the choice between a reliable mini excavator and 6 crews, I would choose the mini excavator. Why? Because the mini excavator never disobeyed instructions. It did exactly what my hands told it to. The mini excavator didn't call in sick or leave work early or say, oh my gosh, my car's broken down, work can't get done today. The technology is more reliable and thus less stressful to organize in bulk. If you can't make something happen unless you've got 6 people to hold something, if just one of those people doesn't show up, then the 6-person job doesn't get done. You have to wait around to, you find another person. And so lower labor demands is an intelligent direction in design. It's also cost-cutting. Creativity is another thing. Now, what I'm talking about is if you can create a technology that gives you more options than the options currently on the market, then it's good, because it's not like you have to use them. It's just, why not have the option, an added way to build? And so with that, this is a new way to build that responds to a number of these, current situations. Now, finally, you have maintenance. If something is easier to maintain, it's preferable over something that's difficult to maintain, both in terms of cost and manpower. Jumping over the hurdle of fitting a boring machine into a shipping container, the next kind of point that we create here is, something similar to a boring company tunnel, where we have a cylindrical concrete tunnel drilled in. Is it 100 feet? Is it 200 feet? It can go in as deep as needed, with very little cost, and incredible safety is the real key. That by having a machine in there, if there's a landslide, etc., as opposed to people in there with wood framing digging this stuff out, people are not hurt, and people don't need to go in until the concrete is set in place. So this creates safety, which is another value. So the tunnels obviously are not very big. They're 7 feet in diameter, something like that. The tunnel is doing a variety of things. It's, first of all, creating parking for self-driving cars, because you can get out, before, let's say the tunnel needs to be quite narrow and it's hard to open out indoors. You can get out here and just send your car into its parking place in the tunnel without needing to have, the wide room, the room to open doors. You can walk into your tunnel by just telling your car to move out of the way, and then walking into the tunnels. There's plenty of room to walk. You've got now self-storage, which is one of America's biggest and most profitable businesses right now, and it's all above ground. You've got self-storage, and this brings up an entire other industry. The ability, rather than taking up valuable real estate for self-storage above ground, and having to look at these, monstrosities as you drive by on the highway, you can actually tunnel in a mile underground and not cause the slightest disturbance in any way, and dramatically reduce real estate cost, and create storage units that organize. You can even create a loop where the self-storage pods are on a rail, an electric rail, so that there's no fumes, etc., and that basically there's a tunnel, and the circle moves around until that pod becomes available, to the front point to open or be, received, and that can rotate all underground, with hundreds of units at a lower cost of construction than any other thing, available. So, but that's an aside. My interest is in a combination of storage, walk-in access, and anchoring, foundation, for earthquakes, for slides, in a variety of ways, and also for vertical boring, because if you have to get up this slope and then put a piece of heavy equipment at the top of the slope. And we'll go back just a little bit so we can see. If you have to climb up an unstable slope, position a machine on an unstable slope, and bore down and lift soil up and get it down without hurting anyone, you're screwed. And that's why these pieces of land are not being developed. If, on the other hand, you tunnel in 100 feet, 200 feet, whatever it is, it's cheap, depending on what you need. So we'll expand this just so you have the concept. It can go in as deep as you want. Then you have the ability to create and install, as you're tunneling, sealing ports of a particular size and nature. And these can be done in one of two ways. They can be done on the side of a tunnel. So if we face the tunnel and we did it perfectly round, and then we put a floor in so that you had drainage and utilities underneath and then a rail, or if it was done perfectly round this way and the bottom bit was not concreted so that you could excavate and run utilities and drainage and stuff down here. You have a couple of different options. You can either do a slice off on the side at key points and cement and concrete this in and go vertical from the side here. Or you can do it in a port in the roof. And what you can do is you can strengthen the amount of concrete that is done right around that particular vertical point such that it can bear a load that the typical areas in the tunnel would not need to bear. And so this could be done if the tunnel was boring circularly, that you wouldn't concrete a particular section. You'd leave a 2 foot to 3 foot area, and then the tunnel would concrete this, so you have both sides. Then you can excavate this very safely by hand, such that you can then come back with the tunneler and fill in a much bigger area of concrete and reinforcement here. And then once the side is done, you can then tunnel vertically. Now, when you've got at least 6 feet in height, you have the ability, now you've got a port in the top that is anchored severely, in the sides. You can now mount a machine that is bolted to the ceiling or bolted to the floor that turns and it's drilling up. And what's so beautiful about this is now gravity is on your side. All of this dirt, as these shafts go up, wants to easily come down. And as soon as it comes down, it wants to fall into the trench, where you can have a conveyor belt just moving the material out to the outside. And that brings me to the other aspect of a slope like this. Because you've got your 45-degree slope, and you could just start the project here and drill in, and you could haul this dirt away, which would just be this dirt right here. It's not much, maybe 20 dump truck loads. No big deal. You could haul it away. But if you want to do more, one of the things that you could do is extend your tunnel out in front here. First of all, then you can build a wall like so. The dirt that's being excavated goes behind the wall and comes back to here. Now, why is this interesting? Well, it further strengthens the slope. It creates flat area for landscape that doesn't otherwise exist. And it eliminates the exporting of the soil all at the same time with the single cost of a wall going in right here, which is very little, because this wall can also be vertical like this, or it can go up 3 feet in, 3 feet in, 3 feet in, and you're generating soil in this area here. You can actually continue it, like this. So, so these are the two techniques for eliminating soil. Now, this same wall technique can also be used to store water using an EPDM membrane, where rainwater and slope water, etc., is basically funneled into a storage tank that is built in concrete on top of this framework right here, such that you then have landscape area on top of the water storage unit, and you've now got year-round available water for drinking and landscaping, and even possible, you can certainly integrate part of it for swimming, should you wish. It's relatively inexpensive to have a concrete storage unit with vertical columns, for shear, and that further strengthens the slope. So you've got, a wide range of approaches, depending on how resilient you want to be, how easy it is to dump off the soil. Because if you have another area of the land, that you're bidding, that let's say there's a steep hole here and the road is here, well, then all that soil could actually be brought in to fill this area. The tunnel could then be done over it with a few anchor points down. And what I like is this is now a cylindrical beam that is very much like the footing for a house. The circle is the strongest shape, so we've now got a footing to tie vertical elements into. So step one is drive in, make the tunnel. Step two is to create an elevator shaft, a vertical cylindrical project, which is way easier than horizontal, as I said, because the soil wants to fall down. And actually, one of the biggest challenges in the drill would simply be to hold enough soil that it doesn't all fall down at once until the sides are concreted. So you're putting the same drilling function, only you're going vertical, and you need way less hydraulics, because down at the bottom here, you would drill a hole, you'd mount your gear setups, which would be a low gear, and you'd have your drill point up through here. This would be extra strong on the side. The motor would be here turning this. It'd all be electric. And as this goes up, this dirt would come down, funnel off 45 degrees, and go out through the conveyor belt, all electric, so there's no fumes, and come out again to be building this wall, to be hauled off, to fill in low spots, etc. The conveyor belt can end in anything. It can end in, the last bit can end in a wheelbarrow, can end in a pile, can end in a dump truck, can end in a shipping container and be hauled off, debris boxes, etc. So the next thing is to drill through the elevator, and the height of the elevator is about 10 feet above, ends the 10 feet above the final roof point. So you have a column back in the slope going 10 feet behind the final roof column. Now, the elevator could be all the way at the back here, or it could be a little bit here. The elevator column becomes useful as the column of a crane that is much more stable than a typical crane for two reasons. One is that the crane is supported in dirt here. Two, the crane is made out of concrete, reinforced concrete in a cylindrical shape as opposed to a square. You've got the circle stronger than the square. And the crane parts are brought up to be assembled up here through the shaft. Now, the way that this would work is you have like an I-beam coming up through here. You have one of two options. You can drill, whether it's a cable or whether it's an anchor, into the slope. It would certainly be more engineered if it came all the way down to this beam here as either a cable or a concrete cylindrical shaft. But what you're doing with this crane is you're not swinging. So what that means is you can have a fixed anchor into the soil. You've now got hundreds of thousands of pounds of vertical pressure that can come down here. And of course the crane wants to go down here, so you anchor it at the back. Again, hundreds of thousands of pounds at the back so that it can't fall down. That gives you your horizontal point here. And you start off with the lighter materials, with the lighter loads. This crane is engineered as part of the building process and structure. Once the crane is in place, you can now haul up, different points for this project, and the load can move in or out on the bar, as well as up and down, and from those 2 points can be maneuvered into place by 2 people that control the crane. This saves enormously on crane rental. It's also, it's not a big cost. If we're looking at a 20-ton crane, something in that range, you've got the electric motor, which you've already got on site for these projects, any of these drill type thing. One can become, the vertical thing can become the crane motor. The motor can be down here with a cable going up through this shaft and tying in with this structure, as the lowering. And one of the things that makes this structure super strong is this is just one tunnel here. And so if we can imagine looking at the face of the slope right here, the width of the house determines how far over the next tunnel is. So that the foundation is sitting on 2 kind of grade beams that are simultaneously parking, underground storage, elevator access, etc. You can have more than 2, but the core design would be to start with 2. And so this gives you your sense of 4 legs, so to speak, because You've got the main shaft at the bottom, which is part of the structure. Then you've got these much smaller, they'd probably be in the 6 to 8 inch range, combination of steel and concrete drilled up as foundations, such that then this crane could use I-beams to set, if we looked at the front of the house at a very small scale, we'd have tunnel, tunnel, vertical posts, and then you can crane I-beams into place to span these gaps upon which you can then rest prefabricated home structures that would be brought in by semi and then craned into position on the house structure with the goal that 2 to 3 people would comfortably be able to rapidly build this entire process on what would otherwise be a completely unbuildable slope. These ports here are much less important, and so just having, as I say, an 8 inch, like a well core where the pipe goes up and then you're able to reinforce and fill it. These pipes can also serve as utility down points, as well as the elevator shaft. For everything easily wants to drain out. And the soil wants to fall down, and be collected in the point right here. So you could drill up to a set point, crane down into this area to prepare these points from above, not having to traverse the slope. From a workstation, in the crane, then crane the I-beams into place, then crane the module units into place delivered by semi. And horizontal I-beams, kind of level with about the grade of the slope, provide shear structure. And this vertical column becomes a notable point of stability for the slope, discouraging slides, and also reinforced by the building structure here. So you would start with the first part of the building structure, and then go up to the next part of the building structure, having some deck here. This could be quite a high box unit with a semi area, right here. The elevator lands here or here on the rooftop. And the rooftop is valuable land for a couple of areas. It gives living space, and under here you have solar with an overhang. So you have a solar roof with an overhang, and you've got a rooftop garden plus this deck, great views, particularly in the land that I'm thinking of, and your whole house is solar. The energy walls, the power walls, are kept down in shade, which it's ideal for maintaining the temperature when you're underground. You also have, with this tunneling technology, the ability to either using the crane, using the soil down here, or tunneling back into the slope, you have the ability of utilizing the natural ground temperature for your heating and cooling in a very effective way. In either scenario, you could just dig down, in this kind of situation here, you could dig horizontally. It doesn't particularly matter. You're well underground, and you've got the places to store all of your utilities. So this core structure can be done with, let's say, a 3-person crew that just builds one thing after another. Once the elevator is in place, once the solar is installed, once the utilities are set up, once the tunneling and boring and all of that is in place, the client has the option to build it out the rest themselves once the structure is in place to finesse things, or to hire the contractor of their choice to finish it, or to continue with the core crew. But my thought is that this is a really valuable order on spec service for a single company. So if you have, the boring company, Tesla Solar, Tesla Powerwall, Tesla Manufacturing, aluminum pressed components can be engineered that are some of the longest lasting. I mean, they'll outlast steel. They can provide incredible built-in insulation with air and and foam. They're very light, which makes for very easy craning. They can be engineered in all kinds of smart ways, and the entire shell can be provided as a shell service that is, where I would really like to see innovation is the ability to have a pre-engineered and on-site stored reverse osmosis system that can take any natural water, any water, street water, gutter water, toilet water, rainwater, any of it, and transform it into something that is healthier to drink than what normally comes out of the tap, and to have that unit stored under here and run electric, 1. 2, a unit that takes all septic waste, the paper, the feces, the nitrogen in the urine, and creates a perfect soil module with self-testing nitrogen pH levels, etc., and clear of bacteria, that can be disseminated on the slope. And once bacteria is broken down, and it's hard to say whether it would need wood chips or a mix with some native soil. The ability to use that material in a technology off the side of the house that slowly stabilizes the slope, whether that's pivoting this crane to the side, and because it's not, you wouldn't need this anchor point if you reeled this in and you're just carrying a human or a few hundred pounds of soil, etc., to stabilize the slope and plant the slope in a semi-vertical garden, such that there is no waste coming from the human body. Nature doesn't create waste. There's no reason we need to. But this can be engineered, and I'm really interested. Gates has about $200 million invested in top-of-the-line composting toilets that manage to do that in a small area for around $5,000. But having that be mechanized in a way that there might be, like, for example, a third tunnel that is a utility tunnel, where all water is sent, all septic waste is sent, all garbage is sent, and a series of top-of-the-line technologies that are modular are in this tunnel that exceed all specs currently used in municipal treatment, that are lower cost, and that are completely sustainable, powered by the solar roof and power wall in on the house. I think is just phenomenal. So the ability to use the conveyor belt to move materials into the site and up on the elevator increases efficiency. The ability to drive up in a semi and have the crane load off in a sequence. Elon Musk talks about the machine that builds the machine is the single most challenging thing. The machine that builds the shipping containers, the boring machines so that they can go out and Tesla semis around the country, the machine that sequences the app technology that lets you as a homeowner take trajectories on your land, send those to Tesla, have Tesla look at the geological and site data and factor a worst case scenario based on the data, and know with certainty that even if there was a landslide, that might just make it a little bit easier if the top of the slope came down, etc. That even if there was a landslide during construction, that this is the absolute maximum cost that your site would take, and that you design the spaces that you want to be in. You design the insulation value. You design whether you want to build it all at once or in stages, because once you build the core elevator thing to the ultimate height of the building and install the crane, you could, for example, move into this module and live in this module while this module was being constructed. Or you could move into this module, live in this module, and a few years later build the second story or another unit. Because there's not that much other than the practical limitations that this crane is basically saying that the last point it can haul up to is this roof. But there's nothing particularly to stop you digging in and building out further, should you decide to at a later date. There's nothing to stop this slope going in and doing a very high slope that goes on much higher, where you basically have perhaps 1,000-foot slope, and you have 10 units all going up through this tunnel, and you have a process of walking in through the tunnel, or even being driven into your tunnel and having an indoor landing space. It's all electric, so there's no fumes, and from there going to the appropriate elevator from which you walk up or down the slope, and an entire development is created, turning liability land into healthy and constructive land.